Bridges. They're more than just concrete and steel. They're symbols of human ingenuity, connecting communities and economies. As a guy who's gotten his hands dirty in countless jobs, let me tell you, building a bridge is no easy feat. It takes careful planning, engineering expertise, and a whole lot of sweat equity. In this essay, we'll break down the complex process of designing a pre-stressed concrete bridge step by step. We'll explore the initial planning stages, dive into the nitty-gritty of structural analysis, and touch upon the importance of safety and durability. Whether you're an aspiring engineer or just curious about the world around you, join me as we demystify the art and science of bridge building. Get ready to get your hands dirty with knowledge. Before a single ounce of concrete is poured, every bridge begins with a plan. This initial phase is all about determining the what and the why of the project. What are we building, and why are we building it? The first step is to define the bridge's purpose. Are we connecting two bustling cities or providing access to a remote community? Next, we need to consider the type and volume of traffic the bridge will carry. Heavy trucks require a much different design than passenger cars. Once we have a clear understanding of the bridge's intended use, we can start thinking about its location. This is where feasibility studies come into play. We need to assess potential sites, taking into account factors like soil conditions, environmental impact and cost. With the potential location in mind, it's time to roll up our sleeves and get our hands dirty with site surveys. This involves sending out a team of surveyors to gather detailed information about the terrain, soil composition, and any existing structures or utilities. Think of it like a medical checkup for the ground beneath our feet. We need to know what we're working with to ensure a solid foundation for our bridge. Meanwhile, traffic engineers are busy analysing traffic patterns in the area. They use sophisticated software to predict future traffic volumes and determine the number of lanes the bridge will need to accommodate. This data is crucial for ensuring the bridge can handle the load, both now and in the future. With data from site surveys and traffic analysis in hand, it's time for the number crunchers to do their thing. Feasibility studies involve evaluating the project from all angles with a focus on three key factors: cost, time, and environmental impact. Engineers, economists, and environmental experts work together to assess the project's viability. They'll consider the cost of materials, labour, and permits, as well as the time required for design, construction, and approvals. Equally important is the environmental impact assessment. We need to minimise our footprint on the surrounding ecosystem, considering factors like noise pollution, water quality, and wildlife habitat. Section 5. Drawing the blueprint's conceptual design. If the feasibility studies get the green light, it's time for the fun part: designing the bridge. This is where creativity meets engineering precision. The conceptual design phase is all about exploring different structural systems and aesthetic options. Engineers work closely with architects to develop a bridge design that is both functional and visually appealing. Will it be a graceful arch bridge, a sturdy beam bridge, or a dramatic cable-stayed design? The choice depends on factors like span length, site conditions, and of course the budget. Section 6. Getting technical structural analysis. Once the conceptual design is finalised, it's time to put the bridge through its paces. Virtually, that is. Structural analysis involves using sophisticated computer software to simulate the stresses and strains the bridge will experience in real-life conditions. Think of it like a digital crash test. We subject the virtual bridge to various loads, including its own weight, traffic loads, wind loads, and even seismic forces. This analysis helps us optimize the bridge's design, ensuring it can withstand the forces of nature and the weight of traffic without breaking a sweat. Section 7. The heart of the matter: pre-stressed concrete design. Now we're getting into the nitty-gritty of what makes a pre-stressed concrete bridge so strong and durable. Pre-stressed concrete is like regular concrete on steroids. By adding tension to the concrete before it's even loaded, we significantly increase its strength and reduce the likelihood of cracks. This involves carefully positioning steel tendons within the concrete and then applying a massive, compressive force to them. Think of it like stretching a rubber band within the concrete, holding everything together tight. The pre-stressing force is carefully calculated to counteract the tensile stresses the bridge will experience under load, resulting in a structure that is both strong and slender. Section 8. Beyond the beams: designing other components. While the pre-stressed concrete beams are the backbone of the bridge, there's a lot more to it than meets the eye. We also need to design the bridge deck, the piers that support the beams, the abutments that connect the bridge to the ground, and the bearings that allow for expansion and contraction due to temperature changes. Each of these components plays a crucial role in the overall stability and functionality of the bridge. We need to consider materials, dimensions, and connections to ensure everything works together seamlessly. And let's not forget about the expansion joints, those gaps in the bridge deck that you may have noticed. These joints allow the bridge to expand and contract with changes in temperature, preventing cracks and damage. Section 9. Standing the test of time, durability and safety. Building a bridge that can stand the test of time requires a keen eye for durability and an unwavering commitment to safety. Durability starts with selecting the right materials. We need concrete that can withstand the elements, steel that won't corrode, and coatings that protect against wear and tear. Regular inspections and maintenance are also crucial for identifying and addressing potential issues before they become major problems. Safety is paramount in bridge design. We incorporate multiple layers of redundancy, meaning the bridge can still function even if one component fails. We also design for extreme events, such as earthquakes and hurricanes, to ensure the bridge can withstand the unexpected. Section 10. From paper to reality, construction and beyond. With the design finalized and all the necessary approvals in place, it's time to turn those blueprints into reality. Construction of a pre-stressed concrete bridge is a complex and fascinating process, often involving massive cranes, skilled labourers, and a whole lot of concrete. Once the bridge is complete, the work doesn't stop there. Regular inspections and maintenance are essential for ensuring its long-term performance and safety. Building a bridge is a testament to human ingenuity and collaboration. It's a complex dance of engineering, design and construction, all working in harmony to connect us all.